Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 14th, 2025, just yesterday. The big punchline is that this paper introduces Rex-Omni, a 3 billion parameter multimodal large language model that hits state-of-the-art, and its reinforcement step boosts F1 at IOU 0.5 on Cocoa from 68.2 to 72.0. The paper is titled, Detect Anything via Next Point Prediction, and the implications for model training are quite significant. In short, quantized coordinate tokens, massive data engines, and geometry-aware reinforcement bring zero-shot detection on Cocoa and LVIS while enabling pointing, text reading, and interface grounding. Also, the authors shared a GitHub repo. You'll find install steps, a quick start detection script, and the Rex-Omni wrapper API supporting detection, pointing, OCR, and key points. There are tutorials and notebooks, a Gradio demo, batch inference examples, integration with SAM, a grounding data engine, and runnable applications plus evaluation utilities. On Hugging Face, Rex-Omni offers downloadable weights around 3 to 4 billion parameters, plus quick start code for detection, pointing, OCR, key pointing, visual prompting, and batch inference. Alright, Figure 1 summarizes what the model delivers and how it does it. The top row shows box-based applications like detection, referring, visual prompting, and interface or layout grounding. The middle band presents the recipe: next token prediction over relative coordinate tokens, plus data engines, and two-stage training with geometry-aware reinforcement, which rewards better localization. The bottom row highlights point-style tasks, covering text reading, object pointing, affordance pointing, key points, and spatial referring. Alright, Figure 2 shows why a language-aware detector is needed. Classic detectors localize well, while multimodal language models read prompts well, yet each misses the other's strength. On the left panels, detectors tag every apple despite the red qualifier, while a multimodal model mislocalizes apples. On the right panel, a box sketch contrasts regression loss, which is geometry-aware, with cross-entropy classification loss, which treats coordinates as class labels and creates harder optimization. So Figure 3 explains the design choices for predicting coordinates. Panel A contrasts 3 routes and favors direct prediction because it stays simple and avoids extra modules. Panel B compares coordinate formats and uses quantized relative coordinates, which means continuous pixel positions are mapped into about 1,000 bins to make language modeling easier. With special tokens, a box needs 4 tokens, while generic digits would take about 15. This cut in length improves efficiency and stability. While Figure 4 explains how the model turns language and images into coordinates efficiently. The diagram shows that the last 1,000 vocabulary slots become dedicated coordinate tokens, which means the model predicts positions as words and stays compact. On the right legend, the phrase and coordinate start and end tokens define the output grammar. At the lower left image, a native resolution vision transformer extracts visual features that the text tokenizer conditions with prompts. Well, Figure 4 explained how coordinates become special tokens. Table 1 shows where the supervision comes from. This table maps each task to its output format, a simple question template, and the public datasets that supply examples. Visual prompting means the prompt includes example boxes so the model finds similar objects. The spread covers detection, referring, text reading, interface grounding, pointing, affordance, spatial referring, and key points, totaling about 9 million public samples. So after Table 1 covered supervision sources, Table 2 presents Cocoa results for common object detection. The headline is that the full model achieves an F1 at IOU 0.5 of about 72%, which exceeds prior multimodal systems and competes with strong detectors. Precision and recall also rise with reinforcement because geometry-aware rewards reduce duplicates and oversized boxes. At IOU 0.95, the advantage is modest, indicating slightly looser box tightness compared with top regression baselines. The shaded rows highlight the SFT variant and the final model, so you can compare the gains directly. Wrapping up, 2 takeaways stand out. Quantized coordinate tokens plus geometry-aware reinforcement make a compact 3 billion model that detects strongly in zero-shot, and the same interface handles pointing, text reading, and interface grounding with very short outputs. The broader implication is a language-native detector that unifies perception, though speed and very tight boxes still need work. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.